We're going to look at vectors in lesson 63. I'm going to intro into these. These are something you will definitely use in Algebra 2. But what is a vector, first of all? Well, a vector is a quantity that has both magnitude and direction. Magnitude, that's kind of a scientific word for length and direction. So right here, I'm going to highlight our vector. Right here is our vector. It has a direction and it has a magnitude. All right, it has a length to it and a direction that it is going. This point right here is point X. Okay, the big dot. That is known as our terminal point. Our terminal point is the end point of the vector. And then up here we have point Y. This is known as our initial point. And the initial point is actually the starting point of a vector. But it has a direction that it's going, and it has a length. How you label a vector, I'm going to make this bigger. Okay, if it's vector R, we write it like so. It's kind of a half arrow. But when that is red, we would say vector R. Notice that it's going to put this on a graph, but not necessarily it's not going to give an X and Y axis all the time. I went ahead to make this one easy and gave us an X and a Y axis. But every vector, you can arrange it to where it's located with a terminal point on the origin and an initial point somewhere else. And now, once we do that, we can see that we have coordinates of 0, 0 and 2, 5. And then we can actually find the length of vector R. And that's what we're going to do in example 2. We're going to find the length in the example 2 of vector V. So how we do this, I went ahead and labeled it. If you look in the examples, example 2, the first picture just has it with no X and Y axis. Well, I redid it just like it did it in the other picture, to where you have an X and Y axis and can see more of the length or the magnitude of the vector. So how we find this is the same way we found the distance between two coordinates. We use the distance formula. So we do square root of x of 2, 2 minus 0, plus y of 2 minus y of 1, 4 minus 0 squared. 2 squared is 4, 4 squared is 16. So therefore its distance is radical 20. I do think it wants it in simplified radical form. So factors of radical 20 are 2 and 10, 2 and 5. So we can take out the two 2's and call it 2 radical 5. That is the distance of vector V. Kind of sounds like a supervillain, vector V. But you just use the distance formula, but you got to figure out two coordinates and find the distance between those. I do want to talk about component form. What component form? Previously we've had ordered pairs. 2, 4 is an ordered pair. That is a point on the coordinate grid. 0, 0 is an ordered pair. That is a point on the coordinate grid. Component form lists the horizontal and vertical change from the initial point to the terminal point. So what our component form here could be, well, first of all, we use these arrows. This stands for component form. Parentheses is for coordinates. So since we look at our change in x, how much does it move horizontally? Well, we can see here that it moves 1, 2 horizontally. So I'm going to put 2 in the, I wouldn't call it the x slot, but more of the change in x spot. And then we see how much it changes in y. And it goes up 1, 2, 3, 4. So we put 4 there. But this right here is an example of component form. And it may ask you to add component forms, different things like that. That's easy, all right? Say it wants you to add, Actually, I'll show you that over there is what I'll do. There's one other thing it talks about. It talks about opposite vectors. It's very basic. Opposite vector of 2, 4 is -2, -4. And that's all I'll say to that. Just the opposite. But let's go ahead and look at adding vectors together. I'm looking at example 3, part B. Page 420. So we are adding vector u and vector v together. Once again, it didn't have the x and y axis on it, but I went ahead and gave it to vector u and t and v so we can add them together. So how we add them is we figure out their component form. What is their component form? So vector u, its component form, well, it has a change in 1, 2, 3, and goes positive and goes up 1, 2, 3, 4. So its change is 3, 4. So that's its component form. Vector v, its component form, well, this one actually starts at the point 1, 0. So I go down changing horizontal first. I go to the left, 1, 2, 3. Okay, it's pretty close. So that's -3. And I went down 1, 2, 3, 4. So -4. So if we're adding vectors together in component form, I'm going to put this over here and write it like so. And you simply add the top to the bottom, and that's 0 in both of them. So its resultant vector, all right, it would be 0, 0. That's the name we would use, resultant vector. And you can kind of tell since it's 0, 0, therefore it is opposite vectors. There's a couple other things it mentions in this, but overall, you know what a vector is now and how to add them. Everything else is just kind of little math things that you'll do with them. But that is the definition of a vector and kind of how you add them and find their magnitude.